Hello, my name is Tom Rummage, manager of the Applications Engineering Department here at Micro-Measurements. Today we're going to demonstrate the proper installation techniques of bonding a C2A series of strain gauge on a G10 glass reinforced epoxy specimen using our AE10 adhesive system. The surface preparation steps used in this video come directly from our application note VMM19, Surface Preparation for Composites. First step is to degrease. We're going to locate the GC6, the alcohol, and because this is a plastic specimen and could be damaged by some of the stronger solvents, the GC6 or isopropyl alcohol is an excellent choice to avoid damage to your part. I'm going to soak the gauze sponge, and then I'm going to degrease the top surface of my beam. The next step is to locate the SCP2, the 320 grit silicon carbide abrasive paper, and I'm going to tear off a single fold about 2 inches long, and I'm going to dry abrade the beam. Ten or 12 strokes is sufficient. We just want to make a little surface roughness. The next step will be to locate the conditioner A, the mild phosphoric acid solution, red tip bottle, and a cotton tip applicator. I'm going to flood the surface of the beam with the conditioner A. This is going to remove any organic contaminants left behind and also put the dust or debris that was sanded into suspension so that we can blot it away. Take a clean, dry gauze sponge, fold it into quarters, and with a single wiping motion, absorb the material off the beam. Starting at the same location, go the other direction. You never wipe back and forth within the same area on your beam with the gauze sponge. The next step is the Neutralizer 5A. We're going to scrub with the Neutralizer 5A a Bo-Peep ammonia solution. Again, flood the surface of the beam. We don't want this to dry while it's on the beam. It would just redeposit the contamination. And then we're going to scrub with a cotton tip applicator. Again, keeping my finger behind the butt of the cotton tip applicator, so I'm going to use sufficient force. I'm now going to take a dry gauze sponge, fold it into quarters, and with a single wiping motion absorb the excess material off the beam. Because this is a composite material and they are fairly hygroscopic, we want to make sure we get rid of all this Neutralizer 5A, so I'm going to use a warm air blower and I'm going to dry the surface of the beam extra. The next step will be to prepare and position the gauge on our glass plate, our staging area. I'm going to slide the gauge out of the packaging as a single unit, lay it down on the glass plate, taking some of the PCT 2M Mylar tape. I'm going to discard the first 2 inches. That might be contaminated and you don't want that contamination on your gauge site. I'm then going to pull off between 5 and 6 inches. It's not critical. I'm going to tug on it so that it doesn't curl up as much as it might normally do. Folding the ends of the tape over to have little handles. I'm then going to entrain the gauge underneath that gauge handling tape. Having positioned it there, now I'm going to transfer it over to my beam. I'm positioning it about midway between, because this is a standard coupon pull test. Alignment is not terribly critical. As long as you keep it straight, it's going to be straight. I'm then going to expose the bonding surface of the gauge, lifting at a shallow angle, and folding it back on itself. The next step will be to mix the AE10 adhesive system and curing agent. We will carefully measure out and dispense the adhesives or the curing agent to the mark 10 for type 10 curing agent. Remembering that the meniscus, the lower line, is the one that we want to use to measure that. I cannot show you pulling this up in the video because I can't do it vertically. First thing you do is you squeeze the bulb tight, draw up the adhesive to the type 10 mark, dispense the adhesive into the center of the resin jar, immediately discard the pipette as it's considered contaminated, and reseal the curing agent. It's very hygroscopic and you don't want it to absorb too much moisture. I'm now going to begin the mixing process. I'm going to stir it for a full 5 minutes. This material is an exothermic reaction, and if you don't continue to stir it after you've started the mixing process, the center of it will get so hot as to kick over the adhesive prematurely. So I'm now going to stir. Note, I am holding the jar by the top of the rim of the jar, so I'm not introducing any more heat than is necessary. This material has a 15 to 20 minute pot life, and we don't want to shorten that even further. The previously mixed AE10 will now be applied. Both to the backing of the gauge and to the surface of the part. We're going to make sure both are thoroughly wetted so that you'll be sure and have a good bond. Be sure to cover a significant area, maybe bigger than you think, so that you have both surfaces wetted. Make sure you cover a big enough area on the part. I'm then going to reposition the gauge using a gauze sponge folded into quarters to squeegee out the excess adhesive. Locating a silicone gum pad, I'm going to place that directly over the gauge, an aluminum backing plate, and finally a Hargrave clamp for applying the clamping pressure to our adhesive system. I'm now going to check to make sure that the aluminum backing plate and the fiberglass beam are parallel to one another, both in this direction and this direction, ensuring that I have even clamping pressure. I now leave it for a minimum of 6 hours if I'm going to cure it at room temperature, or I can elevate the temperature and cure it quicker through an oven process. Our curing process is complete, which was 6 hours at room temperature, or it can be elevated to up to 200 degrees Fahrenheit and accomplished in 30 minutes or less. First off, we're going to remove the clamping fixture, the Hargrave clamp, the aluminum backing plate, and the silicone gum pad. Now, before we peeled the tape peeled the tape up at a shallow angle, now we're going to pull it at 180 degrees back on itself. The adhesive system is excellent in shear, but not terribly good in peel, and so we want to remove the tape and put the adhesive system into shear while doing so. So you can see I'm going to pull the tape 180 degrees back on itself. Now we want to do a quick visual inspection. We want to make sure we don't have any voids or discontinuous behavior, so we're going to zoom in and look at the gauge. We're looking for a uniform bond line color. We're looking for the little fillet around the edge. We're looking for any debris that might have been trapped underneath the gauge and caused it to have a look of a tent pole or some sort of a discontinuous surface. But it appears, based on my quick visual inspection, that this gauge is fairly well bonded and should make a great C2A installation. The last step would be to provide a strain relief loop, and in this case the little enameled wires will do that. And I'm going to then tape down the vinyl lead wire to the beam, so just in case something happens and somebody yanks on the wire, it's not going to immediately pull it off the beam. And here is a picture of the installed gauge.